Hi everyone, Mr. Holtgren here. So we're going to start our second part of Unit 1, which is going to be talking about density. So this is going to be a video that just kind of introduces the concept of density and how we're going to kind of measure it in chemistry class. So density in biology is a little bit different. You might have learned a little bit about this last year, right? But this is a picture showing the population or the population density of the United States of America. So you can see that we're much more dense on the east side of the country versus the west side. Now, again, the West Coast, more dense here, but here in the middle, not dense at all, right? Not many people. Here's a picture showing New York City. You can see during the daytime, high population density. At night, low population density. So in biology, density is a little different, right? When we're talking about population densities, it's dependent upon the organisms, right, that are living and how they may be shifting their living patterns, right? It's going to be a little bit different in chemistry. Now, think about this one. You ever take a magnifying glass and try to burn something? I did that a bunch when I was a kid. Look, I didn't burn my house down. How is that similar to density? All right, now what you should have thought about there is, right, if we have photons from the sun coming through that magnifying glass, that's in a certain amount of volume. But the magnifying glass focuses those down. All of those photons get focused down into a smaller area, right? So we have a start with a certain area, and then it's getting focused down. So all those photons are getting jammed in. So just like the people were getting packed into New York City, the same thing with the photons. Now chemistry, it's going to be a little bit different, but when we're talking about substances, for example, salt. Salt is a combination of sodium and chlorine. They are organized in a crystal lattice, right? So they're structured in such a way so that their density is going to be consistent, right? So every substance that we're going to be talking about, if it's a compound, it has a consistent density, and it's consistent because we know what the chemical makeup is, right? We know how those molecules or atoms are arranging with each other. The other thing that's true with them is it's going to be unique, right? Each substance has its own formula, right? Its own mixture of atoms, so it's going to be unique to that substance. Now how we can calculate this is very simply, or generally speaking, it's the amount of particles in a given amount of space, right? How much stuff is packed into an area, right? That's kind of what we're looking at. And mathematically, we can calculate that by doing mass divided by volume. How much mass is there per volume? Specifically, we'll use these two measurements or formulas here, right? Mass is measured in grams. Volume can be measured in either milliliters or cubic centimeters. So it's grams divided by milliliters or grams divided by cubic centimeters. How do you know which one to use? Just remember, liquids, we're going to use milliliters. Think about the graduated cylinder, right? Cubic centimeters, we're going to use for solids. Remember, length times width times height. And so in either case, it's just mass divided by volume. If you do that, you can find your density. All right, here, watch this short little video.
Okay, grab another one. Okay, softball, what do you think? Pretty good size mass? Yeah? Okay, say sink or float, what do you think?
I think it's gonna float.
It's gonna float. Okay. That's put it in there and see. And actually it does float. So if I was to ask you without making any measurements, knowing the density of water is 1 gram per milliliter, would you think that the density of that softball is greater or less than 1 gram per milliliter?
Greater or less.
Greater or less. This density of this softball going to be bigger than 1 gram per milliliter or less than 1 gram per milliliter? Because it is floating, so it would probably be less than 1 gram per milliliter. And if we could go out and figure out, and we could do that mathematically, determine the mass and volume, and determine the density. Okay. The next one. What is that there? Shot put. Okay, made out of steel or a component of different combined metals there. So pretty heavy.
Yeah.
Pretty heavy. So you think sink or float?
I think it's going to sink.
I think it's going to sink. Okay, very carefully, if you would, set that in the tank and see what happens here. I appreciate you not dropping it in and cracking my tank and putting water all over the floor. So it definitely does sink. So in this case, without making any measurements on this shot put steel ball, do you think it would sink, or do you think the density is greater or less than that of water? Greater. Okay, very good. Let's try the last one. Bowling ball. Pretty heavy? Okay, 10 pounds is the weight on that bowling ball. Okay, so would you say it's got a pretty good size mass?
Yeah.
Okay, sink or float?
I think it's actually gonna sink.
You think it's going to sink? Okay, we'll go ahead and put it in the tank here and see what And would you believe that bowling balls can float? Now, it's got a pretty good mass, you said, but what have we not considered yet? The second characteristic. That's right, the volume.
All right. So what he did there is took you through a few different objects, which we've got pictured here. And what we're going to talk now is how we're going to compare, and that's what they were really doing, right? Is comparing densities. Will it sink? Will it float? Right? And one thing you picked up in there, hopefully, was that the density of water is 1. That makes our life really simple. 1 gram of water, or 1 milliliter of water, weighs 1 gram. So for every 1 gram of water, you have 1 milliliter of water. Okay, so we can use that very easily and simply to compare objects. Now, what we'll do is to do particle pictures. Is we're just going to try to represent that in a picture, a real simple way. 2 things we have to kind of take into consideration with our picture. First thing is we have to represent mass somehow, and we have to represent volume somehow. Now, when we're comparing, we're going to make it real simple, and we're going to make the volume the same for these, okay? Because that, like they did, we're going to kind of take volume out of the picture for now, because that kind of muddies the water. But we're going to keep the volumes the same so we can do a true comparison. So let's do water first, right? If we take water, how I'm going to represent mass is by doing little dots, right, or little particles, and those are going to represent the matter, right, of water that makes it up. So I just randomly put in here, I think I put 10. There's 10 of them in here. Okay. Now what we're going to do is look at the things and how they kind of compared. So the softball and the bowling ball both floated, right? We automatically said that, all right, we're just going to look at the set volume. That hasn't changed. Are we going to have more particles or less particles? More mass or less mass? Yeah, we should have less mass. It's less dense. If it floated, that means it has less mass in the same amount of the same volume, right? The same amount of space, right? So therefore we only have 6 in here. Now again, you could do 5, you could do 7, as long as it's less than water. That's the key. If it's less dense, it has to have less mass in the same amount of volume. Okay. Now what about the shot put here? Shot put, we said sank, right? It sank in that demo. Therefore, it has to have more mass in the same amount of volume. So we jam more particles into our particle picture to represent the fact that it's more dense. And you should be able to see the particles are much more closely packed together, right? And that's going to be something that's more dense. So something that's really closely packed together is more dense. If they're more spaced out or farther apart, it means less dense. So when we're comparing these volume with the same amount of particles, when you're doing this comparison, it's always useful to try to keep the volume the same or adjust the number of particles, right? Just so that it makes it easier to compare from one thing to another. So we did that here by keeping the volume the same. Okay? Okay. All right, if you have any questions, make sure you ask your teacher, and have a great day.